If you have ever stood inside a skyscraper, looked up at its internal skeleton through an unfinished floor, and wondered what was holding the whole structure above the clouds, you were looking at their work. If you crossed the Golden Gate Bridge in San Francisco, or drove across the Chesapeake Bay Bridge in Maryland, or walked through the lobby of Rockefeller Center in Midtown Manhattan, or stood on the deck of any American warship launched between 1917 and 1945, you were standing on steel they made, in furnaces they fired, in a valley in eastern Pennsylvania that most of the people benefiting from that steel have never visited and cannot find on a map. The steel itself has a particular quality to it, cold to the touch in winter, radiating heat back at you in August when a building has been baking in the sun all day. If you press your hand against a structural column in an old building, one of those deeply riveted sections in a railway station or a pre-war industrial building, and hold it there long enough, you can almost feel the temperature of the furnace that made it. That is not poetic license. Steel retains its thermal history in a physical sense. The grain of the metal carries the trace of everything that was done to it. Those furnaces burned in Bethlehem, Pennsylvania, a city of Moravian settlers and church spires of the Lehigh River and the rolling hills of the valley, in the eastern part of a state that was once the industrial heart of the world. The furnaces burned day and night, around the clock, without pause, for over a century. They burned through 2 world wars and a global depression. They burned through strikes, through recessions, through every financial panic and political crisis the 20th century could produce. They heated billets that were rolled into beams and plates and sections that were shipped across the country and around the world and built into structures that are still standing. The furnaces at Bethlehem Steel were not merely a business asset. They were a fact of American life, as permanent seeming as the mountains above them. At its peak, Bethlehem Steel Corporation was the second largest steel producer on Earth. It employed 167,000 workers in 1957. At the height of the Second World War, the company employed nearly 300,000 people, 180,000 of them in the shipbuilding division alone. Its 15 shipyards built more than 1,121 ships during that war, more than any other shipbuilder in the conflict. In a single year, 1943, those yards launched 380 vessels. The company's Sparrows Point plant in Maryland was for a time the single largest steel-making operation in the world, with over 30,000 workers on one contiguous site, a site that had its own railroad, its own infirmary, its own company store, its own streets. In the post-war peak year of 1973, Bethlehem produced 23.7 million tons of raw steel and shipped 16.3 million tons of finished steel, both records, and reported net income of $207 million. They survived the Depression. They survived a violent labor stoppage in 1910 that lasted 108 days and ended with state police charging workers in the street outside the gates. They survived the financial scandal of 1901 that nearly dissolved the company before it was properly incorporated. They survived the Great Steel Strike of 1959, which idled every major American mill for 116 consecutive days and forced the President of the United States to invoke the Taft-Hartley Act to end it. They survived the recession of 1920. They survived the steel crisis of the mid-1970s, laying off tens of thousands and closing divisions, and still came back to post-record revenues in 1981. They retooled, expanded, and rebuilt. They forged the armor plate on the USS Missouri, the battleship on whose deck Japan surrendered. They laid the steel for the Empire State Building. They cast the sections that hold the cables of the Golden Gate Bridge. And then, after nearly 140 years of making things that held the world together, Bethlehem Steel Corporation filed for Chapter 11 bankruptcy protection on October 15, 2001. and dissolved completely 2 years later in 2003. How does the second largest steel company on Earth, a company that armed 2 Allied armies, built the American skyline, and employed 300,000 people at its wartime height, end up destroyed? And what really happened inside those walls, in those boardrooms, across those decades of decisions that the public at the time never fully saw? Those 2 questions are what this account is about. They will be answered, but not yet. Chapter 1. The son of a Lyria stable. Charles Michael Schwab was born on February 18, 1862, in Williamsburg, Pennsylvania, a crossroads of fewer than 500 people in the folded limestone hills of Blair County, a day's ride from the nearest city of any consequence. His father, John Anthony Schwab, was a woolen worker and blanket manufacturer who also kept a livery stable. His mother, Pauline Farabor Schwab, was the daughter of German immigrants. The family was Catholic. They were not poor, but they were not much more than comfortable, and young Charles understood from an early age that comfort and ambition do not keep the same hours. The family moved to Loretto, Pennsylvania, when Charles was still a boy, a village of around 300 souls tucked into the Allegheny Mountains near the campus of St. Francis College, smaller than Williamsburg, and quieter, the kind of place that keeps you if you let it. Charles enrolled at St. Francis but did not finish. He left after 2 years, without a degree and without a trade credential, and with nothing beyond a very specific conviction that wherever the productive action of the world was happening, he intended to be there. He found his first work as what he later called a singing cabbie, driving passengers from Crescent down to Loretto in a horse-drawn carriage, entertaining them with ballads on the road to pass the time and earn a larger tip. One passenger, struck by the young man's energy, gave him a travel book about the wider world. Schwab later said that book changed everything. Loretto, population 300, became visibly, urgently insufficient. He was 17 years old. With his parents' blessing and no particular plan, Schwab went to Braddock, a steel town on the Monongahela River just outside Pittsburgh, and took a position as a clerk in a general store. He was not there because of steel. He was there because it was somewhere, and Loretto was nowhere. But Braddock was steel. The smoke came off the blast furnaces of Andrew Carnegie's Edgar Thomson Works, the most modern and productive steel-making facility in Pennsylvania, and settled over everything in the town. The men who worked the mill came into the store. One of them told Schwab there was a position available at the works. Schwab walked through the gates of the Edgar Thomson Steel Works in 1879, barely 17, and took the most junior physical job available, stake driver, dragging chains and setting plumb lines in the ground, while the furnaces roared overhead and the entire mechanical apparatus of a mid-Victorian steel mill operated at full volume around him. The heat in a steel plant at that level of production is not what most people imagine when they picture heat. It is directional. It comes at you from the furnace mouth like a hard wind, drying your eyes and cracking your lips from 20 feet away. You feel it in your chest before you feel it on your face. What happened inside Andrew Carnegie's works was that the foreman noticed something unusual about the stake driver from Loretto. He had a memory like a recording instrument. He memorized the specifications of every furnace, every rolling schedule, every process parameter on site, not because he was asked to, but because the information interested him. He could diagnose a problem in a heat by the color of the flame from 100 feet away. He worked hours that made the regular shift workers look idle. He also, and this was the quality that Carnegie himself came to prize above the technical mastery, had an exceptional instinct for people. He could walk into a work area where productivity had fallen and have it running at capacity again without anyone quite being able to explain what he had done differently. By 1887, at the age of 25, Schwab was named General Superintendent of the Homestead Works, Carnegie's flagship plant, and one of the largest and most complex industrial facilities in the Western world. By 1897, at 35 years old, he was president of the Carnegie Steel Company itself. He had entered the industry as a stake driver at 17. He had reached the top of American heavy industry without ever earning an engineering degree or an MBA. The achievement was a function of memory, relentless effort, and a charm so natural it never appeared calculated. In 1901, Carnegie decided to sell. Schwab brokered the negotiations with J.P. Morgan. The transaction created United States Steel Corporation, capitalized at $1.40 billion, the first billion-dollar corporation in American history. Schwab became its first president, 39 years old, running the largest industrial enterprise on earth. He lasted 18 months. The culture of U.S. Steel, conservative, hierarchical, bureaucratic in the manner of a bank, was antithetical to everything that had driven Schwab. He clashed with Elbert Gary, his fellow executive, over strategy and autonomy. He could not bear to run something he had not built. In 1903 he resigned. The Bethlehem Steel Company, as it existed in those years, was a business of long history and uncertain future. Its origins ran back to April 8, 1857, when Augustus Waller and a group of investors incorporated the Saucona Iron Company in South Bethlehem, Pennsylvania, a modest works set up along the south bank of the Lehigh River to roll wrought iron railroad rails. The company had grown, changed its name, broadened its product line to armor plate and naval guns, and established itself as the primary defense contractor for the U.S. Navy. But by the turn of the century it was financially fragile. Joseph Wharton, the Philadelphia industrialist who had founded the business school at the University of Pennsylvania and was Bethlehem's largest shareholder, put the company up for sale in 1901. He tried to consolidate it with the British armaments group Vickers Sons and Maxim. The deal fell through. Schwab acquired a controlling interest. He borrowed heavily, absorbed the debts, survived a brief scandal involving the transaction, and on December 10, 1904, incorporated Bethlehem Steel Corporation, a new holding company that combined the Bethlehem Works in Pennsylvania, shipbuilding facilities at the Union Iron Works in San Francisco, and additional concerns in California and Delaware. He became president and chairman of the board. He was 42 years old. He was carrying significant personal debt. He had an antiquated plant in the Lehigh Valley, a workforce accustomed to the confrontational management style of his predecessors, and a conviction developed during his years at Carnegie's Works that the one thing the American construction boom of the early 20th century would always need more of was a structural steel beam it could not yet buy from anyone. Chapter 2. The beam that built the American sky. In the first decade of the 20th century, every architect in America who wanted to build tall was fighting the same problem. The conventional structural steel beam of the era, the I-beam, rolled from a single ingot, was relatively narrow at its flanges. Under certain loading conditions, particularly the combined vertical and horizontal loads that a tall building must carry in wind, the narrow flange performed poorly. Buildings were either overbuilt at enormous cost or constrained in height by the structural limitations of available sections. An English steelmaker named Henry Gray had spent the better part of 20 years developing a rolling mill that could solve this. Gray's universal beam mill used a series of specially configured rolls to shape a structural section with unusually wide flanges. Sections that were deeper, broader, and structurally superior to anything then available in the American market. They were also, because they used material more efficiently, cheaper to produce per unit of load carrying capacity. Gray had tried to interest American steelmakers in the concept throughout the 1890s and early 1900s. None of them wanted to commit to the capital expenditure his mill required. Charles Schwab bought the American rights to the Gray mill process in 1905. He did so with money he had borrowed, and a certainty that was, at the time, not supported by any firm evidence from the market. No major buyer had committed to purchasing wide-flange structural sections in quantity. No architect had specified them in a completed building. The Gray mill was a bet, large, expensive, and unhedged on Schwab's reading of where American construction was going. Installing the mill at Bethlehem's Socon plant complex along the Lehigh River proved more difficult and expensive than anyone had estimated. The foundations presented unexpected ground conditions. Equipment shipments were delayed. Technical problems in the rolling configuration required repeated modification. By the time the Gray Universal Beam Mill went into production in January 1908, it had cost triple the original budget, and Schwab still had no committed buyers at the scale required to service the debt. What Schwab needed was a signature structure, a building so prominent, so visible, so unambiguous in its ambition, that architects and engineers across America would learn to specify Bethlehem sections and no other. The Gimbel Brothers department store building in New York came first. Then the Woolworth building on Broadway, at the time of its completion in 1913, the tallest skyscraper in the world, which used Bethlehem's wide-flange sections throughout its steel frame. The Merchandise Mart in Chicago, the Opera House in Chicago. One by one, as the architects of a country building faster than it ever had before, looked for structural solutions that were stronger and more economical than what they had been using, they arrived at the Bethlehem beam. The advantage Bethlehem held was extraordinary and exclusive. From 1908 until 1927, 19 years, Bethlehem Steel Corporation was the only producer of wide-flange structural sections in the United States. Every skyscraper, every long-span bridge, every major industrial building that used this form of beam during those 19 years bought it from a single plant complex on the south bank of the Lehigh River in Pennsylvania. The Gray mill itself ran continuously for nearly 90 years, with only minor upgrades, until steel making in Bethlehem ceased altogether in 1995. But even before the mill had proven its commercial viability, the first of what would become a recurring pattern of crises arrived at the gates. On February 4, 1910, nearly 9,000 workers at Bethlehem's Pennsylvania works walked off the job. The men's grievances were not complicated. They wanted Sunday off. They wanted the laborers' base rate raised from 12 cents an hour, a rate that in 1910 represented a wage barely sufficient to sustain a family in the housing within walking distance of the plant. They wanted a revision to the bonus system, which theoretically rewarded skilled workers for output, but in practice compelled them to work unpaid overtime in order to qualify for pay that should have been their base rate. Schwab refused all of it. He did not negotiate. He called in the Pennsylvania State Police, the first deployment of state police to break an industrial dispute in the history of Pennsylvania, and officers charged a crowd of strikers and bystanders on horseback, beating men, women, and children in the streets of South Bethlehem. The images that appeared in newspapers across the country horrified the reading public and did lasting damage to Schwab's personal reputation. A congressional investigation followed. Federal legislation on working hours in the steel industry eventually resulted, in part from the 1910 strike. The workers returned without winning their demands. The wages barely moved. The company kept rolling steel. What the 1910 strike established, and what its legacy would mean for everything that followed, was a template for the relationship between Bethlehem's management and its workforce that would persist for the next 70 years. Not negotiation, not partnership, war, conducted under a temporary ceasefire. The men who were beaten in the streets in February 1910 raised sons who entered the plant with the memory of that day in their families' spoken history. Those sons raised grandsons. The Steelworkers Union, when it finally organized Bethlehem in 1941, did so after a bitter secondary strike that management had refused to prevent. The adversarial foundation laid in 1910 was still structurally present in the contract negotiations of the 1970s and 1980s. The detail that never made the national headlines in 1910, and that mattered enormously in the longer arc of the company's history, was this: the 12-cent hourly rate that Schwab refused to raise in 1910 was less important than the principle of management's unilateral authority over working conditions. When the United Steelworkers of America finally negotiated that authority away decades later, they do so with a historical grievance of 60 years accumulated weight behind them. The resulting work rules were rigid in proportion to the violence of the original suppression. But in 1910, the gray mill ran, the beams went out, and the buildings went up. The company survived. The next crisis would be far larger, and the company would emerge from it transformed into something that neither Schwab nor anyone else in 1910 could have imagined. Chapter 3. The Arsenal of America. By the outbreak of the First World War in August 1914, Bethlehem Steel had an annual steelmaking capacity of 1.1 million tons and employed 15,600 people. It was the dominant supplier of armor plate, naval guns, and ordnance in the United States, a position built through decades of investment in heavy forging equipment that no civilian manufacturer wanted to replicate and no competitor had the patience to develop. When the European powers began mobilizing in the summer of 1914, Bethlehem's order books changed in a matter of weeks. Britain needed warships, and it needed them faster than its own yards could produce them. France needed artillery shells by the million. Russia needed anything available. Bethlehem began filling contracts simultaneously for the British, French, and Russian governments, while also expanding its supply of armor plate and naval ordnance to the growing U.S. Navy. The profits from the first 18 months of European war were the largest in the company's history to that point. In 1916, the year America was still officially neutral, Eugene Gifford Grace became president of Bethlehem Steel. Schwab remained as chairman. Grace was the product of a specific managerial philosophy: measure everything, control everything, share authority with no one, and extract the maximum from every asset on the balance sheet. He was methodical, where Schwab was intuitive, cold where Schwab was warm, and absolutely committed to the idea that the company's purpose was to produce steel at the lowest possible cost and sell it at the highest possible price, with the profits flowing upward to those who had made the decisions. Grace also had an appetite for personal compensation that would eventually plant the seeds of the company's financial destruction. In 1929, at a time when Bethlehem was reporting strong earnings, Grace received a personal bonus in excess of $1.60 million, approximately $27 million at today's values. Between 1911 and 1931, Grace and 12 other senior officers collectively received more than $36 million in bonuses. A group of stockholders sued in 1931 to have the money returned, arguing that the bonus program constituted a misuse of company funds. The courts did not compel repayment. The pattern, generous executive compensation unmoored from the long-term financial health of the institution, was established in those years, and it was never meaningfully reformed. The Second World War remade Bethlehem Steel at a scale that still resists easy comprehension. From the moment the United States entered the conflict in December 1941, Grace directed the company's entire capacity toward war production. Every furnace was pushed to its limits. Every shipyard worked 3 shifts. The open hearth furnaces ran continuously, day and night, producing armor plate for ship hulls and tank decks and the walls of armored vehicles. Between 1941 and 1944, Grace pushed total production to 101% of the company's rated capacity, beyond what the engineers had said the plant could sustain. Between 1940 and 1945, Bethlehem produced more than 73 million tons of steel. That total represented nearly 1/3 of all the armor plate and gun forgings used by the United States in the entire war. The company's 15 shipyards built 1,121 ships, more than any other shipbuilder in the conflict, and more than any other single contractor in any category. In 1943 alone, those yards launched 380 vessels, fleet carriers, destroyers, destroyer escorts, heavy cruisers, cargo ships, tankers. The USS Massachusetts was built at a Bethlehem yard, the USS Hancock and the second USS Lexington, the armor plate welded into the hull of the USS Missouri, on whose deck Japan's representative signed the formal instrument of surrender on September 2, 1945, came from furnaces along the Lehigh River. At its wartime peak, Bethlehem employed nearly 300,000 people, of whom 180,000 worked in the shipbuilding division. The Sparrows Point plant outside Baltimore became during the war the largest steelmaking operation in the world, with 36,000 people on a single 100-acre site. It had its own railroad, its own freshwater system, its own medical facilities. It had housed its workers in a company town called Sparrows Point, a grid of streets owned by Bethlehem Steel, where the rent was deducted from the wages and the company store sold the groceries, until 1968, when the company finally sold the residential properties. In Bethlehem, Pennsylvania, and in Lackawanna, New York, and in Johnstown and Burns Harbor and Coatesville, and every city where Bethlehem had a major facility, the plant and the community were one continuous thing. 3 generations of families worked the same company. A man would apprentice at 17, follow his father into the open hearths, watch his son enter the rolling mill 30 years later. The social infrastructure of the city was organized around the shifts. You knew when a heat had been tapped because the sky above the plant changed color. You could hear the steel moving in the night. If you lived close enough, a constant low percussion, metal on metal, and the rush of compressed air that became so familiar, it was the sound of home. To stand inside a working blast furnace complex in its productive years was to experience something that the word industrial inadequately describes. The heat from the furnace mouth was not ambient. It was directed, aggressive, arriving from the tuyers and the casting floor with enough force to push you back a step. The sound was layered. The deep continuous roar of the furnace itself, the high shriek of the rolling mill, the mechanical percussion of the overhead cranes moving billets across the floor, the hiss of water hitting hot metal. The smell was sulfur and coal gas and hot iron, and it embedded itself in your clothing and your hair and could not be washed out. Men worked in that environment for 12-hour shifts, for decades, and their lungs and their hearing carried the record of it for the rest of their lives. In 1945, Bethlehem's gross annual sales reached $1.33 billion, nearly 10 times the $135 million recorded in the year before the war. The company had armed and shipped an Allied victory. It had demonstrated a productive capacity that no competitor anywhere in the world could match. It was, in the autumn of 1945, the most powerful independent steel producer on Earth. The word that matters in that sentence, for understanding everything that followed, is was. Chapter 4. The first cracks in the armor. The post-war years felt like an unending vindication. American consumers returning from the war with wages saved and spending deferred for 4 years began buying automobiles and refrigerators and washing machines at a rate that required sheet steel in quantities the pre-war economy had never consumed. The suburban housing boom of the late 1940s and 1950s demanded structural sections and galvanized steel in volumes that seemed, from inside the executive offices along the Lehigh River, as though they might increase forever. Bethlehem's plants ran at high utilization. Profits were robust. The pension fund, the health insurance obligations, the legacy costs of a growing army of retirees, all of it seemed manageable against the background of steady revenue. It was not manageable, and the people responsible for managing it knew it less well than they thought they did. Eugene Grace, who had been running Bethlehem since 1916 and who served as chairman until 1957, had made a decision during the peak profit years of the 1940s and early 1950s that would metastasize into a crisis 20 years later. He chose, repeatedly, not to make the full actuarially required contributions to the company's pension fund. The argument, insofar as it was made explicit, which it often was not, was that the capital was better deployed in plant expansion and in dividends. What it actually amounted to was a transfer of future obligations to future management, while present management collected present bonuses. When Grace retired in 1957, He left behind a pension liability that was understated, an executive compensation structure that was indefensible, and a production technology base that was beginning to age dangerously. The technological problem arrived from an unexpected direction. Japan's steel industry, obliterated during the war, and rebuilt from the ground up with Marshall Plan assistance and American technical guidance, had been equipped with basic oxygen furnaces, a technology developed in Austria in the early 1950s that could reduce a heat of steel from molten iron in approximately 40 minutes. Bethlehem's standard open hearth furnaces required 8 to 12 hours per heat. The productivity differential was not marginal. It was transformative. The Japanese also installed continuous casting systems, which eliminated the ingot casting and reheating stages of conventional steel making by pouring liquid steel directly into semi-finished shapes. Together, these two technologies reduced the cost of Japanese steel making dramatically below the cost of American production. Bethlehem's management was briefed on these developments in the 1950s. The company did experiment with continuous casting on a limited basis. It began installing basic oxygen furnaces, but slowly, and in a piecemeal fashion that maximized short-term capital conservation at the expense of long-term competitiveness. The argument made internally was that existing equipment still functioned, that replacement capital was very large, and that the union agreements made rapid operational change complicated. All of those things were true. None of them made the decision correct. In 1959, the accumulated tensions between the steel industry and the United Steelworkers of America produced the event that many analysts, looking back from the vantage of the 1980s and 1990s, would identify as the turning point from which the American steel industry never fully recovered. On July 15, 1959, workers across every major integrated steel mill in the United States walked off the job. The formal dispute was over work rules, management's demand to be able to change the number of workers assigned to a task, to introduce machinery that reduced staffing without union negotiation. The union refused. The gates went closed. The strike lasted 116 days, from July 15 to November 7, 1959. President Eisenhower invoked the Taft-Hartley Act on the 116th day, ordering workers back under an 80-day cooling-off period while negotiations continued. The Supreme Court upheld the law when the union challenged it. The workers returned. Management won none of the work rule changes it had demanded. The labor agreements remained structurally intact, but the damage was not in the outcome of the strike. The damage was in what happened in the 4 months the mills were dark. American buyers who could not wait for domestic steel began importing. Imports jumped from 2 million tons in 1958 to 5 million tons in 1959. They did not return to pre-strike levels. Tom Crowley, then general manager of Bethlehem's Johnstown plant, described what happened to the market in the year after the strike came to an end. The big customers came back, he said, but we began to lose the byproducts: nails, field fence and barbed wire. Those small categories, nails, fencing wire, basic flat products, never fully returned. And the buyers who had discovered during those 116 days that Japanese and European steel was available, and cheaper, and of acceptable quality, had discovered something they would not forget. Bethlehem's leadership interpreted the 1959 strike as a crisis that had been navigated, a brief interruption from which the company had emerged with its essential structure intact. They were right that the structure was intact. They were wrong that the strike was over. The market had shifted beneath them in ways the production reports did not show. The company pressed on through the 1960s, posting respectable profits, acquiring additional plants, and expanding capacity. In 1969, as a long boom appeared to be continuing, Bethlehem broke ground on a new corporate headquarters building at 1178th Avenue in Bethlehem, Pennsylvania. The architect was Haynes Lundberg Whaler of New York. The building was to be 21 stories and 332 feet tall, the tallest in the Lehigh Valley. It would be built in a distinctive cruciform shape, a plus-sign footprint, specifically designed to provide corner offices on every floor for the company's large cadre of vice presidents. Construction began on August 25, 1969, overseen by Chairman Edmund F. Martin and President Stuart S. Court. When it was completed and opened in August 1972, the building was named Martin Tower in honor of the chairman who had presided over its construction. It cost $18.50 million. At the moment of its opening, Bethlehem Steel employed more than 120,000 people. A retired draftsman named Leonard Gentlecore, who worked on the design of Martin Tower and spent decades at Bethlehem Steel, later said he associated the building with executives who were out of touch with what was actually happening to the company's competitive position. "This is where the money went that the workers never got," said Fran Mayatako, whose father worked at the plant, watching the building be demolished in 2019. She was not wrong. Before investing a meaningful amount in continuous casting technology that would have reduced production costs and kept the Bethlehem works competitive, the company spent $18.50 million on a headquarters building whose primary architectural innovation was that it provided more corner offices than a conventional rectangle. 2 years after Martin Tower opened, the rosy world turned suddenly gray. In 1982, Bethlehem Steel Corporation reported a loss of $1.50 billion. It was a record. It was also the first of 5 consecutive years of losses. The number that terrified the financial analysts who studied it was not the revenue decline. Revenues can recover. The number that terrified them was the ratio of retirees to active workers, and the cost structure implied by that ratio. By 1982, for every active worker producing steel for Bethlehem, there were more than 2 pensioners drawing from the fund that Grace had left underfunded, and that subsequent management had not adequately strengthened during the years when it could have been done cheaply. By 2001, when Robert Miller arrived as chairman and CEO, that ratio had reached 7-to-1, 7 retirees for every active employee. The annual cost of healthcare, pensions, and associated benefits for Bethlehem's 130,000 retirees, active employees, and their dependents had reached $300 million per year. The company could not produce enough steel, at the prices the market would pay, to cover those obligations and also invest in modernization, and also service its debt. The arithmetic had become inescapable. The closures proceeded in sequence. At Lackawanna, where 20,000 people had worked as recently as 1965, raw steelmaking ceased in 1983. The blast furnaces, H furnace and J furnace, photographed for the last time in a widely reproduced 1983 aerial image that showed them still billowing, went cold. The Lackawanna coke plant survived until 2001. The last operating unit, a 13-inch bar mill, closed shortly after. The city of Lackawanna, which had been built around the plant over the preceding 80 years, faced a fiscal crisis that lasted a generation. The tax base collapsed, city services contracted. Families who had lived within walking distance of the mill for 3 generations either found new work in a regional economy that had also been built on industries now in decline, or they left. Steel and metal processing employment in the Buffalo-Niagara region, of which Bethlehem was the dominant component, had reached 35,000 jobs at its post-war peak in 1969, representing 1 in every 5 manufacturing jobs in the region. By 1980 it was 18,000. By the mid-1980s, after the Lackawanna closures, it had fallen to fewer than 5,000. The workers who lost those jobs, the majority of them over 45, with skills specific to integrated steelmaking operations that no longer existed in their region, largely did not find comparable employment. Studies of the workforce in the aftermath of the closures found that most of the laid-off steel workers over 50 never worked again in manufacturing at equivalent wages. The majority took early retirement at reduced pensions, lived on those pensions, and watched their cities shrink around them. Robert Ortwine, who spent 40 years at the Bethlehem Works before retiring, described the competitive dynamics with a plainness that is more devastating than any analytical account. They had the brand new mills, they had cheap labor, and we could not compete with them, he said. Then he added, but we didn't have to end up where we did. Somebody made choices. He was correct on both counts. At the home plant in Bethlehem, Pennsylvania, the last blast furnace, C furnace, the final operational unit in the 135-year history of ironmaking on the site, was shut down on November 18, 1995. No ceremony was held. No executive from Martin Tower came down to the furnace floor. The local paper, the Allentown Morning Call, published a brief notice. The men who had worked C furnace for years stood and watched as it went through its shutdown sequence. A blast furnace being shut down after decades of continuous operation makes a particular sound, a long, deep subsidence, as the internal temperatures begin their first drop from the thousands of degrees at which they had burned. The sound is not dramatic. It is simply large, and then it is absent. Bethlehem had built its corporate headquarters, the cruciform Martin Tower, when it employed 120,000 people. By the mid-1990s, that workforce had been reduced by more than 2/3. The building stood largely empty in its upper floors. Its corner offices, the specific feature that had justified its extravagant shape, occupied by an ever smaller cadre of executives managing an ever smaller operation. The building was closed entirely in 2007. In May 2019, a demolition crew used 485 pounds of explosives to bring it down in 15 seconds, watched by hundreds of people from across Bethlehem and the Lehigh Valley, many of them the children and grandchildren of workers. This is where the money went that the workers never got, said Fran Mayatico, watching the dust column rise above Bethlehem on that May morning. The Burns Harbor plant in Indiana, Bethlehem's most modern facility, built in the 1960s, and the company's most productive site in its final years, was shipping 5 million tons of finished products annually by the late 1990s, generating more than half the company's revenues. It was not enough. On October 14, 2001, the board of Bethlehem Steel Corporation met in emergency session. The vote was taken. On October 15, 2001, the company filed for Chapter 11 bankruptcy protection in the United States Bankruptcy Court for the Southern District of New York. Robert Miller, who had arrived as chairman and CEO on September 24, 9 days after the September 11 attacks, bringing with him a reputation for managing industrial crises from his role in the Chrysler bailout of the early 1980s, made the announcement. Chapter 11 does not solve our problems, Miller said. It provides us a process and framework within which we can address and explore the significant issues facing the company. He had assessed the situation clearly. What he said next, to the Washington Post, was equally clear. Since September 11th, what was a declining marketplace has become a free fall. September 11th had accelerated what was already terminal. The construction industry had already slowed sharply before the attacks. The recession of 2001 had already compressed steel demand. Bethlehem had been posting losses. The attacks ended whatever residual possibility remained of a short-term improvement in market conditions. Miller was not making an excuse. He was describing the final acceleration of a trajectory that had been set long before he arrived. Between 1997 and 2001, 30 American steel companies had filed for bankruptcy. Bethlehem was the largest. The bankruptcy process ran for 2 years. The company attempted to find a buyer who would take the operating plants as going concerns and preserve at least some of the workforce. No single buyer emerged on those terms. In April 2003, the court approved the sale of Bethlehem Steel's operating assets to International Steel Group, a company assembled largely by Wilbur Ross from the wreckage of other bankrupt American steelmakers LTV Steel, Weirton Steel, and now Bethlehem. The purchase price was approximately $1.50 billion. International Steel Group acquired the Burns Harbor plant in Indiana, the Sparrows Point complex in Maryland, and the remaining operational facilities. The corporate structure Bethlehem Steel Corporation itself, with its name, its history, its identity as an institution, ceased to exist. The site of the original Bethlehem Works along the south bank of the Lehigh River in Bethlehem, Pennsylvania, is today a 10-acre arts and entertainment campus called Steel Stacks. It opened in 2011. 5 of the original blast furnaces survive, preserved in place. They were too large and too structurally integral to remove economically, and the decision was made to incorporate them into the new cultural space. They rise 285 feet against the Pennsylvania sky. The Hoover Mason trestle, which once carried iron ore from the dockside stockpiles to the furnace tops, has been repurposed as an elevated walkway, with plantings and benches, and interpretive signage explaining what was made there and how it was made. The Wind Creek Steel Stage at Steel Stacks hosts concerts. Music Fest, the annual outdoor music festival, draws 1.5 million visitors to the base of the old furnaces every summer. The furnaces stand over all of it, immovable and unchanging, while the culture below them rotates through the seasons. Historic Bethlehem Museums and Sites offers guided walking tours of the complex. A wind turbine research facility shares the adjacent land with the National Museum of Industrial History, which opened in the surviving machine shop building in 2016. The Lehigh University Library holds extensive archives from the company's history. The Steel Plant Museum in Lackawanna preserves what the Western New York plant left behind. Individuals and organizations have collected what they can of the physical and documentary record. The knowledge that built the company has not entirely disappeared. It lives in retired workers who can still, decades after their last shift, describe the precise color of a heat running correctly, the sound of a properly adjusted rolling mill, the feel of steel at temperature. It lives in the buildings it made. The Empire State Building, still standing, the Golden Gate Bridge, still carrying traffic, the Chesapeake Bay Bridge, still crossing the water. Those structures will outlast most of the institutions that have replaced what Bethlehem was. Jack Welch, the industrialist regarded by his generation as the model of American corporate management, was once asked whether he could have saved Bethlehem Steel if he had been placed in charge. His answer was immediate. I don't think Christ himself could have saved it. That is either a verdict on the institution or an absolution of the people who made its decisions. It is probably both, and it is certainly incomplete. Institutions do not become unsavable by accident. They become unsavable by the accumulation of decisions that proved, in aggregate, to be the architecture of failure. Charles Schwab died on September 18, 1939, in a small apartment in Manhattan. He had spent his last years unable to afford the taxes on his properties. His holdings in Bethlehem Steel were, by the time of his death, virtually worthless. He died more than $300,000 in debt. He is buried in a private mausoleum at St. Michael's Cemetery in Loretto, Pennsylvania, the mountain village he had left at 17 to drive a carriage and sing ballads and find his way to a steel mill. He had built an institution that outlasted him by more than 60 years. He had built it on the conviction that you had to invest in the new before you could see the returns, and that the history of an industry was not the same thing as its future. The institution that survived him forgot that conviction, or chose to set it aside, and so it ended. The 5 blast furnaces at Steel Stacks still stand. They are lit at night by spotlights from below in orange and amber and white, the colors of the fire that once burned inside them. You can walk beneath them on the Hoover Mason trestle and look up, and the scale of them is still astonishing. They were not small things, and what went on inside them was not a small thing. If your father worked there, if your grandfather heard the mills running through the night, The sound so constant it was simply the sound of home. Then you already know what was lost here, and you know it in a way that no account can fully render. Tell us what you remember. Put it in the comments below. The history of what was made in those furnaces, and by whom, and at what cost, that history belongs to the people who lived it. It should not go unrecorded.